Hey everyone, welcome back to my channel. So today we're going to be diving into one of the cleanest, most reproducible reverse proxy setups that you can build on NixOS. This is going to be powered by Traefik, and then we're going to secure it with SOPS and scale it with modular service definitions. If you ever wanted to declaratively expose services like Jellyfin, automate your TLS certs, and lock down access with DNS level ACLs, all without using a single Docker container, this video is for you. So I'll walk you through a dynamic Traefik module that auto loads service routers from the disk. We're going to secure our secrets management using SOPS and a hardened dashboard exposed over HTTPS with Cloudflare DNS challenge. We're also going to be talking about CoreDNS integration for internal resolution and forwarding, and as well as setting up a native Jellyfin service. Everything's going to be modular and built to scale across your Homelab or internal network. All right, so let's get started. All right, so I'm starting with a fresh NixOS install. The first thing I'm going to want to do is enable SSH so I can manage my server remotely. Um, I'm also going to enable Flakes and add SOPS and age to the packages list. So SOPS is short for Secrets Operations. It's a command line tool for managing encrypted files like YAML, JSON, and environmental files. We'll need it later when we integrate SOPS NIX module to handle our secrets declaratively and securely. And then you have Age. Age is a modern encryption tool that uses compact public, and private key pairs. Fast minimum. It's perfect for infrastructure when flows, especially when paired with SOPs. So I uncommented the services that OpenSSH enable equals true, and then I added the line right here to enable flakes. And then I rebuild using the command sudo NixOS rebuild switch. Real quick, I'm going to get the IP address of my server, and then I'm going to try to SSH into it. So it's 20.115. I'm going to do SSH. I'm going to do SSH Nix at 20.115. All right, cool. Now I can SSH in. All right, the next thing I want to do is I want to lay down a clean directory structure for my Nix configs. So I'm going to start by creating a top level folder called Nix config. So inside this folder, I want to copy over my hardware configuration.nix as well as my configuration.nix files. Um, these will form the base of my system setup. All right, then I want to create two key directories called modules and then one called secrets. And then within modules, I'm going to add another folder called services to house my service specific modules like Traefik as well as Jellyfin. And then lastly, within inside the services, I want to create a directory that I'm going to call Traefik hosts. This is where I'll define individual host modules for Traefik. It's just going to keep things modular, readable, and easy to scale. All right, so now I'm back on the top level directory, the Nix config. I want to talk about the flake.nix file right now. So within this file, this is the file that powers our NixOS configuration. Inside it, we define our inputs. These are external sources that Flake depends on. We have the unstable Nix packages as well as the stable Nix packages, in case we want to mix stable packages as well as unstable together. And then I have the SOPS NIX package, which brings in the module that lets us manage secrets securely using SOPS. And then the VS Code server, this is optional. I have this because I'm using VS Code right now, and I want to be able to use all its features. And then within the output blocks, we define what this flake actually produces. We have our target system architecture, x86. And then we import Nix packages for that system, giving us access to the packages and modules. And then with inside NixOS configurations, we define a host called NixOS. This is our host name for the server we're working on. And this is the full NixOS configuration built using the Nix package lib NixOS system. We pass in special arguments, which just makes all of our inputs available to the modules, which is really handy for referencing things like SOPS, Nix later. And then finally, we're listing out some modules that make up the system. We have our configuration.nix, which is our main system config, as well as the SOPS Nix OS module, which is the module that wires in SOPS support for secret management. Then also have, again, the VS Code server, which is completely optional. But however, this setup gives us a clean, reproducible NixOS system that has built-in support for encrypted secrets. So I'm going ahead and save this, and then I'm going to run the command NixOS rebuild switch, and then add the flake. All right, so the next thing I want to talk about is the traefik.nix module. Let me go ahead and open that. So within the traefik.nix module, I'm importing all the host definitions from the Traefik host directly. So this basically means that each host, like Jellyfin, gets its own file. And then I'm using the built-in .read directory to scan the folder and lib.map attributes to import each one dynamically. And then I merge all the routers and services configuration using the lib.make merge. So pretty much this just means that any Nix file within the Traefik host directory, which is right here, will get imported automatically into this traefik.nix file. And this just keeps my config very scalable. I just drop a new host into the module file in the Traefik host directory, and then it's auto-loaded, right? So if you look at the environment files, I'm using SOPS Nix to manage the secrets remotely or securely. The environment file line pulls in a decrypted.env file at runtime, so Traefik can access things like the Cloudflare API and email without exposing them in plain text. Under static config options, you can think of this as your traefik.yml file. We're going to define our entry points. So we have the web, which is port 80, which redirects traffic to HTTPS. And then you have web secure, which is port 443, which handles TLS termination. And then I use Cloudflare DNS challenge for acting, which means Traefik can automatically issue and renew certificates for my internal domains, like test.genyhome.net. And then I've enabled both access logs, um, and then it's structured for JSON. And then the access logs include headers like X forwarded for and CF connecting IP. If I ever want to use something like Cloudflare tunnels, I can trace the real client's IP even behind proxies. And then looking at the dynamic config options, right here you have your routers is equal to your merge routers, and services is equal to your merge services. So this is just pulling in the merge routers and services that I talked about earlier that's coming from the Traefik host folder. Each service module defines its own routing rules, and then Traefik will piece them together at runtime. Then I also have middlewares. I have default headers as well as an HTTP redirect scheme, and then I have a whitelist as well. And then lastly, I'm looking at the firewall rules. I have to open up port 80 and port 443 in the NixOS firewall for Traefik to be able to do its job. So this setup gives me full control over my reverse proxy, again, both declaratively, securely, and this is all without containers. All right, so now let me walk you through a Traefik router definition in NixOS that exposes the Traefik dashboard securely over HTTPS. So I already have it configured, and this is what this Nix module looks like. So essentially, it's similar to a config.yml file for Traefik, or labels if you're using Traefik labels. We have the router name, which is just Traefik. This is just a label. You can name it anything. But here it matches the dashboard host name rule, which sends requests to traefik.test.genyhome.net. And this will be your internal dashboard domain. The entry point that it uses will be web secure, which is HTTPS. And then the service, since this is the Traefik dashboard, it's just going to be API internal, which is Traefik's built-in dashboard and metrics API. And then for the TLS block, for the server resolver, we just have Cloudflare's DNS challenge to issue out certificates via Let's Encrypt. And then for domains, we have we cover both asterisk wildcard test.genyhome.net as well as the base domain test.genyhome.net. So the wildcard certs can work across your internal services. I've also got another module for Jellyfin.nix as well. This will be another router definition. It's the same declarative style, except for the services we actually have to point it to the URL and port number that our Jellyfin will be running on, which will be this server as well. I'll talk about that here shortly. But this is the basic template that you can use, as long as it's nestled within inside of the Traefik host directory. The traefik.nix module will import any of these files directly into it. All right, now let's get the Cloudflare DNS API Token next. I went over this before in a few of my previous videos, so this should be pretty familiar if you already using Cloudflare. So once you log in, you want to go to your profile and then API tokens, profile, API tokens. And then you'll hear your click create tokens. And then you're going to scroll down and you're going to choose create custom token. And then you're going to fill out the name. And then for permissions, you want to choose zone read. And then you also want to choose zone DNS edit. And then for zone resources, you want to choose the specific zone. And then you want to select your root domain. And then after that, you can click continue to summary, and then you'll create the token. And then make sure you copy the token. So the next thing we want to do is we're going to go into our secrets directory, and we're going to create a .env file. And then we're going to add the following variables for the DNS API token, as well as your email address into cloud for your Cloudflare. All right, so now let's secure our Cloudflare credentials that we have, this .env file, using SOPS, NIX, as well as age. This way we can safely store secrets like our email and API key and, like repositories like Git without exposing them. So first thing we need to do is we need to an age key pair for encryption. This lets make sure the SOPS key directory exists first, and then we generate the key. So what you want to do is you want to run this command, which is just going to create a directory for your SOPS age. And we're just placing it under the .config /SOPS age. And now we're going to run the command, which is similar to SSH keygen. It's age keygen, and then we're going to output it into that directory we just created. We'll name it keys.txt. So essentially, this creates a private key file at that directory. Then SOPS will use this to decrypt secrets during activation. So what you want to do is you want to copy this key, and now we can encrypt our traefik.env file. And this is the command we want to use. So this command is SOPS and then age, and then that's the public key right here. And then the input type wants to be binary. Then the output type is also binary. And then it's saying encrypt the traefik.env file, and it's going to output it as traefik.enc.enc. So let's run this. I've had a space, or I didn't put a space in between the key and the input type. So we're going to run this again, make sure that it works. All right. And as you can see, the encrypted file was created. So if I run the command, if I try to cat.enc and it's encrypted, you can't read it. So now you can delete the original .env file if you want. I'm going to go ahead and remove it. Then we just have to encrypt it. And then you can also verify. You probably should do this before removing the unencrypted version, but you can verify that it was encrypted by running this command right here, SOPS tag D, which is decrypt, and then the encrypted file. And then you should get the two variables that we encrypted. So the next thing that we want to do is we need to add some lines to our configuration.nix file just to make sure that we're able to utilize this encrypted file. So I'm going to open up configuration.nix, and towards the bottom, I'm going to add this line of code for SOPs. So with this, it's just saying that this key, the secret is only decrypted at runtime, which is stored under run dash secrets, um, which is actually TMPFS backed, and then it's wiped at reboot. So your encrypted file will stay safe, and your system can stay reproducible. And then also, this is moving on to the next part of this video. You want to also add this line of code for CoreDNS, which we're going to be setting up next. We're going to go ahead and enable that. So save this file. We're not going to rebuild yet, so until we go over the CoreDNS portion. All right, so now let's talk about CoreDNS. So CoreDNS is a flexible plugin-based DNS server. It's written in Go. It's designed for the modern infrastructure, thinking containers, service meshes, and internal zones. Unlike traditional DNS servers, Core DNS is by default very modular. You can define exactly how it should behave using a simple config file. It can serve static zones, forward queries, cache responses, and enforce ACLs, all done declaratively. So let me walk you through my NixOS module for Core DNS that sets up Core DNS to serve a custom zone for genyhome.net, while also acting as a secure forwarder for other DNS traffic. So let's break this down. If you look at the zone file, this just defines genyhome.net. It's a very typical zone file. You have the name server, genyhome.net, and then you have the wildcard dot test, which will be pointing to the server that you're running traffic on. In this case, it will be the same server that I'm using now, should be 115. And then if you look down at the ACLs, so we only have only whitelisted subnets and IPs can query. Everything else is blocked. And then if you look at forwarding, it's forwarding to my main DNS server. And then this file is injected via the environment.etc. Keep your secrets safe. And then you can toggle this module, going back to the config file, configuration.nix file. You can toggle this module by pushing enable equals true, making it easy to include or exclude from your NixOS system. And then I forgot to mention this, but you also need to update your firewall rules as well. So you want to uncomment these two lines of code, and you want to add port 53 for both. That is your DNS. And then we also need to, before we rebuild, we also want to import these modules, the Traefik as well as the core DNS modules as well. So we can do that at the top. So once we save, we're now able to run the command sudo nixos rebuild switch. So once it's done building, we should be able to run a system ctl status Traefik. and it should be up and running. And it's active, enabled, and running. And then we can do the same thing for CoreDNS as well. And that one also is up and running as well. And now we're going to check out the Traefik Dashboard to see if we're able to reach it. All right, so let's see if we can reach the Traefik Dashboard now that everything is up and running. Before you do that, however, just make sure that you update whatever system you're using, update your DNS server to point to the IP address of the server that you're working on, that CoreDNS is working on, which is 20.115 for me. Now I'm going to go to my web browser and I'm going to see if I can reach it. All right, and Traefik Dashboard is up. That means it's working as intended. If I look at the HTTP routers, it has both the Jellyfin one configured as well as Traefik. We haven't set up our Jellyfin.nix file yet, so we can do that now. All right, so the last thing we're going to talk about is the Jellyfin.nix module for the actual service of Jellyfin. And it's really simple. We're just using the enable equals true, which enables Jellyfin using NixOS built-in module. We have user and group Jellyfin. It runs on its own user and group for isolation. And then under the built-in JSON, we're just adding the host IP address and the port that it's going to be running on. And then we're opening up the port 8096. So this is really simple for Jellyfin. You save this, and then just make sure that you import it under the configuration, under your configuration.nix file at the top. You save that, and then you rebuild again. Once it's done rebuilding, we can do a system CTL status Jellyfin, and it is up and running. So let's go back to our web browser real quick and see if we can access the Jellyfin webpage. All right, so if you look at the Traefik dashboard, we do have a router rule for jellyfin.test.gmail.net. So we're going to try to access this now. And as you can see, we are redirected to the quick start guide. So it looks like everything is up and running. Yeah, that's pretty much it for the full walkthrough. Utilizing flakes and encrypting our secrets with SOPS and age. We built a modular directory structure. We declaratively deployed Traefik with secure routing and wildcard TLS. We even layered in CoreDNS to serve our own internal zones to forward traffic securely, all managed through reproducible NixOS modules. If you found this helpful, please drop a comment, share your own setup, and like and subscribe. This code will be available on my GitHub page, as well as the steps to as what I did on this video. All right, thanks for watching. Until next time.